Hello everyone, it's May the 16th, Sunday, and then it's quite late now. It's 10:15 p.m. my time. I went to a Brazilian barbecue today. It was quite fun, uh, and I had a taste of cachaça. It was a good liquor. I quite enjoyed it. I mean, it tastes similar to what I used to drink when I was back in China. You know, those spirit, that's Chinese spirit. It has the same kind of feel to it, so it's a little bit familiar for me, but it's good. It tastes pretty good. I like the feeling of those high alcohol content drinks that kind of burns up your nose. And they give you the warmth right after you swallow it. It's interesting. It's interesting. I mean, I think I went there. I got there like 2 o'clock, and then kept drinking, beers and then liquor until 6. So I actually got a little bit tipsy, but sobered up now. So let's do the challenge today. All right, let's take a look. I don't remember about that. Never mind. Let's do this. Binary tree camera. Interesting name. Given a binary tree, we install cameras on the nodes of the tree. Okay. Each camera at a node can monitor its parent, itself, and its immediate children. Calculate the minimum number of cameras needed to monitor all nodes of the tree. Okay, so this is the binary tree, so we need one monitor, okay? So the parent and the children. This we need, okay, 2 cameras. The number of nodes in the given tree will be in a range of 1 to 1000. Every node has a value of 0, so it's nothing about the values. It's just about the tree. So that means the minimum number of cameras. It's the minimum number of cameras to monitor a tree, right? So given a tree, any binary tree, within a camera can monitor its parent, itself, and its children. So one camera can monitor multiple levels, right? Multiple levels. 3 levels. We're talking about 3 levels. Children, itself, and like this is the example. Right? One camera can monitor 4 nodes, right? One camera can monitor 4 nodes. And in this case, one camera monitors 2 nodes, one camera monitors the other 2 nodes. I mean, if we think about greedy, I mean, the number of cameras. Can we do this like using dynamic programming? The sub problem is, if we're given a tree, right? We're given a tree, and we have a root of a tree, and we have children, right? So we say the minimum number of cameras needed will be, for the tree itself, it will be, if I put a camera on myself, on the root, then it's on the root, then I have the left and the right child already taken care of. And then we want to find the minimum on the right child, the minimum on the left child, given that the root has already been monitored. Right? That's one situation. Or all right, I'll think again. So we have a root, and we have a left child and a right child. So ideally, this type of problem is we have a root, and we say we find the minimum on the left child, and we have to find minimum on the right child, right? And then we come to the current root. Now we want to cover the root, so we can put the camera on the root, right? That's one solution. Or we can say, no, it depends on the child. If the left child has the camera on the root and the right child has the camera on the root, then we can spare the camera on the current root, right? So what are the possibilities? We have a root, and then we got whatever left tree and a right tree. And then the left tree is the minimum number of cameras that's cover the entire left tree. And the right tree is the minimum number of cameras covering the right tree. Now, it depends on whether the camera is on the root of the left subtree, or not. If the camera is on the root of the left subtree or on the root of the right subtree, then that's the result. We don't have to set up another camera on the root. But if the camera is not on the left subtree, the root of a left subtree or the root of a right subtree, then we need to set an extra camera on the root. Okay? How would you, let's take this as an example, see if the idea works, right? So this is the binary tree. So we say on the root, we don't know. So we need to check the left subtree and the right subtree. The right subtree is a none, so we don't care about it. So we'll go to the left subtree. Now at the left subtree, we have the root. I don't know. I want to go to the left subtree and the right subtree, right? And then on the left subtree, I want to go to the left subtree and the right subtree. Now the left and right is none, so we're coming back to it, right? We're coming back to it, and then say I want to cover the current node. Now because the left and right are both none, and I'm a leaf node, so I say, for me, the only likelihood is I am the camera, right? I am the camera. So for the right subtree, so for this, I'll say I'm the camera. For this, I'll say I'm the camera, right? Now coming back to this, now what we see is this is the camera, this is also the camera. So these two are both cameras, and they say this do not need to be camera. And then this will be camera. Then we have like 3 cameras instead of 1. How do we change that? It's like when we aggregate, right? We come back here, we see both the left and the right. We say the minimum number of cameras for the left and right subtree come out as 1. And this is also 1, right? But that's not right, because I can set this, and then we can remove 2. Hold on. Let me think. How did the recursion work? If the left subtree, say the minimum number that can satisfy the left subtree and a minimum that can satisfy the right subtree, and what we find is they both have it on the root, right? They both have it on the root. Yeah, because if we go to the bottom, yeah, this has to set, and then when we come back up, then neither of them need to be set. Or we say if we come to the root, we come to the leaf, right? If we come to the leaf, we always not setting the leaf, because we can always set the parent, and then that will cover the leaf, because the leaf is the end node, right? The last node. we can say the leaf node, we do not have to set it. Because if we set the leaf node, then in order to cover, then we have to set both leaf nodes. Like if we set leaf node, if we say we're going to set leaf node, now all the leaf nodes will be set. And that's just tremendous number, and then it's a waste, right? It's a waste. So we can say when we hit a leaf node, then we always not set it. And we always set the parent of the leaf node because that is the most economical. Otherwise, right, yeah, think about like a tree with a leaf node, right? There are only two ways to do it. If you have a tree like this one, right? The most basic binary tree. If you think about that is the if you think about that as the unit of a binary tree, then we can either set the leaf nodes and don't set the root, or we set the root and don't set the leaf nodes. Then apparently setting the root will be more economical, right? Will be more economical. So we say, okay, if we don't set a leaf node, let's say whenever we find a leaf node, we just don't set it, right? Whenever we find a leaf node, we don't set it, and whenever we find a leaf node, we don't set it, and then we come back up to the parent node, and for the parent node, we'll check on the leaf nodes, right? If any of the leaf nodes that is not set, but then we create a problem, right? We create a problem because we say when we go to the leaf node, like when we go to the left subtree, we say we'll cover the entire thing. The camera will cover the entire thing. Now you're telling me that if it's a leaf node, that I don't cover it. But that's a conflict, right? That's a conflict. Or maybe we can work this thing like bottom up, like not using dynamic program, but just greedy, right? Just greedy. Can we do it like just greedy? We say we go all the way down to the leaf node, right? And if it's a leaf node, we don't set it, and we always set the parent of the leaf node, right? And once we set a parent, think about binary. Let's draw the binary tree. So we have a leaf node, right? So leaf node is always not setting. If the leaf node not setting, then the parent node has to set. And leaf node not setting, then the parent node has to set. Leaf node not setting, the parent node has to set. I don't know, but I can give a just like run some test cases. I think what can run is what, 0, 0, 0, 0, 0, no, no, and then no, no, 0, right? Let's see how many do we need for this. I think it's 3. Yeah, this is going to be 3. The way I think about it is the leaf node never use it, right? So we have to get this one. Okay, leaf node not using it, we have to get this one. Leaf node not using it, we have to get 1, 2, 3. Okay. What if it's like a more populated binary tree? Like a complete binary tree. Take a little bit more levels. So if a complete binary tree, and we say leaf node don't get it, right? If leaf node don't get it, then the parent node get it. Leaf node don't get it, the parent node get it, and then the parent node, because the leaf node, then that's also 3, because the parent node. Hold on. The parent node, but this one covered already. And the parent node, well, this covers the parent node. That's also 3. Leaf node. So then if you want to maximize it, right, then we say for the second row, if it's the second row, then we say only one of them needs to be camera. I don't know, man. This doesn't seem easy to me. So if we say the left side and the right side, right? If we break out left and right, and I also want to know if there's any node. Like given a tree, a parent and two children, any one of them, if any one of them has camera, it can cover. If the parent has camera, it can cover both. But if the child has, it can only cover the parent, it cannot cover the other one. Now, if we throw these into it, and we say, and look into this, right? And then we don't know, so we go to the child, and the child is a leaf node. So we don't care. That basically means it's a nothing. And then if the child is also a leaf node, that means a nothing. So it returns nothing. So we say both child is nothing, so I have to have the camera, because that's always the optimal solution for a 3-node tree. And for the left, what's going to happen? We have parent, and we say, okay, we don't know, so we're going to look into child and child. And this is, again, a situation where that's that. And then we say, they both. So maybe, I don't know, let's try, let's see how this one works. All right, and more. I think that's the one this is the one I was working on. I think this is 3. 1, 2, 3. Let's see if it's 3. It is 3, right? So maybe it does work. Like we still split, right? From the root, and split the left subtree and the right subtree, and they are going to construct, like find the minimum number of nodes that make it work. Like minimum number of nodes on here and minimum number of nodes on here that allow the coverage of the entire subtree and the entire subtree. And now I'm coming here, now we're going to determine on the makeup of these, right? So if any of these, because we already say that cover the entire thing, and this also can cover the entire thing. So if any of these has a camera, then I do not have to have a camera. But if none of these have camera, then I have to have camera. So that's the decision. And the only thing is, if we do this, naturally at the leaf node, we will say we'll have camera, and we'll have camera. And then we're coming back here, it's hard to determine. So what you say, if it's a leaf node, we just, by default, we don't have camera. A leaf node by default, we don't have camera. Let's try this idea, and I'm not confident. I think, I don't know, but it's worth a shot. Right? It's worth a shot. Let's try this, and if it doesn't work, then we hopefully we have enough brain power to think about something more. But currently, that's the way I'm going for. Yeah, I'm not 100% sure. Very, very uncertain. It seems alright, but I don't know. I just don't know. So what we're trying to say is the number. Okay, maybe I can just write directly here. Anyway, we can say if root dot left, if not root dot left and not root dot right, that means I'm a leaf node. So I'm going to return right? Turn 0. So I don't put camera on me, right? Otherwise, I'm gonna say self dot. So left min on the left, let's say min L equals self dot min camera on the root dot left. Right? And I'm also going to say if root dot left, there we go. Alright, I think we can do it this way. Else 0. Min right equals self dot min camera cover root dot right if root dot right else 0. Right? So that's the min left and min right. And then what I would say is I'm gonna also use a number, right? Number is gonna be 0, so I can use any other number to represent that the camera is there. So we say if 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 root, so the only chance that I am going to be changing is if root dot left and root dot left and not root dot left dot val and root. Oh, okay. Oh, hold on. No. If root dot left, right, and root dot left dot val, or right, just at least one of them makes has the right dot val. At least one of them has camera. Then we can say we just basically going to return min left plus min right, because one of my children has the camera, so it covers me. I don't have to have camera. Else, that means none of the children have camera, right? None of the children have camera. Then we say I must have camera, right? Then we say root dot val equals 1. I must have camera, and we're going to return min left plus min right plus 1. And let's see what we have. But I already see a bug. We'll have one node that's going to be bug. That's going to be bug. So even if this passes, it's still going to be bug. Because if I do one node is supposed to need to be 1, but mine will be 0 because of this. I mean 0. And mine will always 0. So or I say, if I see that both my children has, if I see both my children has, on my left and right, if I see both my children has camera, then I say that's a waste because I can have a camera and the children doesn't have to have camera. Ay, ay, ay. Yeah, if I'm a root, if I'm a leaf, like if I have a right left tree, right, and I have a right tree, and I have both the root, it has camera on it. How do I deal with this? And we say that's already the minimum number. I remove it. I mean, like you have to, right? So like the children situation is either neither has camera, like for the current root, and I have two children, right? So if neither of the children has camera, then I must have camera. If one of the children have camera, then I do not need to have camera. If both the children have camera, that's the situation. Like we don't know how to resolve. If both children has camera, and we say it's the minimum number of camera on the left tree is with the children has camera. That's actually not true in the sense of both children has camera. Right? They have a root and then both children has camera. And does that mean like one of them can do better? Like can remove one of the camera. How do we approach it? And I say leaf node doesn't need to have camera. If there are at least two levels. So it also depends on how do you know there's only one node, right? I also need to pass on the level. Like we say, if it's a leaf node, more than one level. It's more than one level. I feel like it's still gonna be trouble. Like if we add a level here, and we say I want to turn 0 if it does not have, if it's yeah, like if we return 1 if it's the only node, and otherwise we return 0. Like if it's like deep, then we always return 0. If it's leaf node, you can go. I'm just trying to like justify if like leaf nodes will always be empty, like no camera on the leaf node. If we have camera on the leaf node, right, then we don't have camera on the root. Like in this situation, we can have camera here and no camera here, have a camera here and no camera here. Then we have a camera here. Right? In this case, 1, 2, 3, 4, 5. Of 5 levels, right? Of 5 levels, the best scenario will be we have the cameras in the 0, 1. It's like odd levels, right? If we have camera on all the odd levels, hold on, maybe this is just even an odd level stuff, right? If we have a binary tree, whatever the binary tree it is, like doesn't matter what binary tree it is, there's like levels, right? If there are odd numbers of levels, 1, 2, 3, 4, 5, like odd numbers of levels, let's go back down to the test case. Right, if we have odd numbers of levels, I'm just setting another complicated, slightly complicated. I think this is the same as we have done before. I think I need a little bit more. No, and no, and no, and 0. There we go. So in this case, we have 1, 2, 3, 4, 5. 5 levels, right? And we know on 5 levels, if we go this and this, then we cover everything, right? 0, 1. So level 1 and level 3. We have level 1 and level 3, that covers everybody already. That's true, right? And what if we have even numbers of, right? Even numbers. Like, what if we get everybody to be 0? I don't know, but let's give it a shot. Like, everybody's a 0, 1, 2, 1, 2, 3. That's full, right? Let's give a little bit more, right? So that's a fully loaded. Now in this case, we say we always want to avoid the last, because we can, an even number, we can go this, the first, like 0 and 2, or 1 and 3. But the last levels always have more nodes. So we need to count the number of nodes at each level. And they always go like either like even, like it's always like 0, 1, 2, 0, 2, 4, right? It's always odd number or even number of rows that will be having the cameras. Now the job is just to find out, I think the key is to find out the sum of nodes on all the even levels and the sum of nodes on all the odd levels. And then we use the smaller of the two. That will be the solution, because each node can cover the one above it and the one below it. That means it's always going to be skipping, right? We have this, and we're going to skip when we have another one. So the problem is this the even rows or the odd rows. So we're going to change our strategy. Instead of doing this, we're going to count the even rows and the odd rows. How do we do that? Well, it's going to be BFS, right? So we need a queue. And I think I can handle it. So queue, we're gonna put root in it, right? And then we have sum even 0, sum odd equals 1, because no, odd will be 0, even will be 1, because we do 0, 1, 2, 3. So this is level 0, right? And then it's going to be a while queue, right? And we'll have a temp. We say for node in queue, so each node coming out, how do we know it's even or odd? Well, I think when just get sums equals 0 and 0. That's 0 and 1. Oh, 1 and minus 1. Minus 1. No. No, 1 and minus 1 will be pointing to the same thing. Because minus 1 is pointing this, but 1 is pointing this as well. We need... How would you do this? Like... plus 1 and minus 1? Plus 1, minus 1. So currently at 0 position, I'm at plus 1. And then minus 1, plus 1, minus 1, plus 1, minus 1. I mean, just plus 1, and then every time we just swap it. Swap it, swap it, swap, 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 swap. That shall work. So say this is going to be this, so we're going to say what? Say plus 1. Every time I do this, and I'm going to plus 1, and I will plus 1 again, and mod 2. We can do plus 1 mod 2. we can do +1 mod 2. Keep plussing 1 and a mod 2, so it go back to the front. Keep plussing 1 and mod 2, plussing 1 and mod 2. And mod 2 I think is also easy to handle because mod 2 is just we apply a mask of 1. Yeah, it's a mask of 1. So we can say I equals 0, right? So, and then this, we say sums I plus equal to 1, right? And then if no.left, temp.append node, if node.right, temp.append right node.right, right? After we done, we say I equals I plus 1 and 1, right? So that gave me the residual. And after that, I want to say Q equals temp. So going back up. So after we've done all this, we will have computed the sum of all the nodes on the even rows, the sum of all the nodes on the odd rows. Then the job right now is to return the minimum and the sums. Okay. Let's apply this. It's a very different thinking process. And see if this one gets it right. It gets it right. Single one shall be right. It should be 1. My answer is 0. There's something wrong here. Why? Oh, I think I should start. We should start with a maximum. Start with math.inf and math.inf. If we start with math.inf, no, we cannot stop. Oh my god. So no, we start with 0 because we need to accumulate. And we need to do the minimum. Oh my goodness. It has a 0 in it. That's the thing, right? That's the thing. When we come out, we need to eliminate the zeros because it cannot be 0, right? So it's going to be return sums 0, if not sums 1, right? Because 0 is, yeah, because the only possibility is for sums 1 to be 0. Sum 0 has to be, it's the root node, right? So sum 0, it has to be sum 1. So let's be this, else, then we say mean sums. Then we can pass this test case and try somewhere else. I don't know. I'm just putting in some random stuff. I hope it's random enough. Right, and it's a very, very convoluted new way of doing this. Okay, let's try this one. I don't even know. It's very convoluted. No. My answer is 8, but the expected answer is 6. So it's not correct just to count the even and odd rows. I mean, That's too convoluted. Let's take away some of these and run it again. See if we still have a wrong answer. Yeah, this one's correct. Okay, how about we just remove these? See how it goes. Aha! The error is in the last fill. How about this? This will be the same, like this. Yep. All right, so what I do is I count. So that's 1, 2, 3, skip, 4, 5, skip, 6, 7, 8. Right? That's my way of counting. Or I say, skip this 1, 2, 3, 4, 5, 6, 7. Right? But the answer is 6, which apparently is 1. And then 2, 3, 4, 5, 6, or 5, 6. Yes, it is 6, which means it's, we'll take this one, I'm going to do it again, 2, but I don't do this one, I do 3 here, right? I do 3 is here. So I do here, then I have to count this and this, but in this subtree, I do this one, 1, 2, 3, 4, 5, 6, right? Which means I might be able to count. So it's the same idea, but it's not counting, right? It's not counting the global, but every time we go to the, like if we here, we go left and right. Maybe we can combine these two ideas together. Here, left and right. Right is nothing. I don't contribute. Now we go to the left. Like how much this can provide. But then we have to count from here or count from here. Which is fine, right? I mean, for a root, how do we count? For a root, if I count the root, then we don't count the children. Then we go for count here and count here. It doesn't feel right to me, man. It doesn't feel right to me. But that's the fact, like we are here, right? And then we count this, and then we count these two. But the thing is, we count this, that will give us bad result. We shouldn't count this one. So like at each level, like we swap, right? We swap, and then instead of having this and this and this, at this level we skip it and we count this, and then this and this. So this is only 4 instead of 1, 2, 3, 4, 5 instead of 5, right? I mean that's the idea. Is how we count. So like at each level, there's a choice. There's a choice at each level. We can choose at this level. We can choose to, or we like just to count from here, right? We count from here. We say either this, 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 or this, this, and we get a value. The minimum, actually that is the minimum on this side. We're using BFS to find the minimum on this side, and we use BFS to find the minimum on this side, and to determine whether, so for the left subtree and the right subtree, we use BFS to find the minimum, and then we get this. But why don't I use, it has to, like we go left and right, right? If we look in the left, we look in the right, and we use BFS to find the left, we use BFS to find the right, and afterwards we analyze whether the root needs to be included. So when the root here, so when BFS on the left and BFS on the right, well, right is 0, so BFS on the left. So BFS on the left will be 1. Yeah, we cannot do like BFS on the left because it's, no, we say, how do we say this? Because we say if we find the BFS on the left, that's going to give you, BFS is like this, boom, boom, right, boom, boom, or boom, boom, and boom. Neither is the optimal solution, right? Neither is the optimal solution. And we just keep saying, go for this, go for this, go for this, go for this. Like how do you know when to use the BFS to do this? This is a, yeah, direct counting is not correct. I feel like I'm getting close, right? So we do BFS, because I skip. Yeah, I just, this thing, it skips. It skips. How do we handle this? Like if we have a level, right? We have a level of covered. But sometimes we can skip one. But we don't have the entire level covered. Left subtree and a right subtree, right? If I say I want the left subtree, the minimum number, and I want to know if this one is included or not. And then this one will go to the left subtree, and then go to the right subtree. And the left subtree, this one with the left subtree is nothing. Right subtree, so I say this one I want it, right? I want it. And if I want it, and okay, and now I'll go to this one. I say if both are wanted, and I will come back, and I say if I'm okay, and one of you can not have it. Oh. Or like we also return if I am a leaf node or not. Like I return, also indicate whether I'm a leaf node, and this will see this is good. This has a camera, but it's also a leaf node, which means the camera can be overturned, right? And then I need to look this. If this does not give me anything, say this is empty, then I know for me, no, because this is already the best solution for here, right? The best camera solution for the subtree. Oh. Let's go back to the drawing board, to the basics, right? So we have a root, or we have a left and right. Now the situation is either we have root as good, right? Root is good, and then left and right we don't contain anything. That's one situation, and then we can find out the number of that we'll get, right? Or root is not taken, and then we take the left, and then leave the right. So we only take the left. So given a tree, I'm gonna save this, but like given a situation of this, right? This, it's either I have the root, right, and then we go on, or I have the left tree, then we go on, or I have the right tree, then we go on. So for any three nodes, only one of them, we can say one of them is taken. And actually not one of them is taken. It depends. It depends. It depends. If I take the root, then they don't have. If I take the root, then the left child don't have to be, and the right child don't have to be. If I do not take the root, and I only take the left child, right, then the right child has to be covered by somebody else, right? Have to be covered by somebody else. So try to see if it can be covered by somebody else. This is like also like we say there are only three scenarios. All right, and then some scenario will fail, right? Will fail. So in this case, I say this and this, right? Now we don't have a right tree, so either I am good or this is good. So I say if I am good, then we go on. Then this cannot have, right? This cannot have. This has to be covered by somebody else. And then when we look at here, and then this one has a requirement that I do not get covered, right? So I need either this or this. So I can say I want this, that, and then this is not covered. So this requires covering. So I can say either this is covered or this is covered, right? Either this or this, and we say, okay, I want this to be covered, and this do not cover. So this one requires this to cover, and here this is covered, so this do not cover, and then this do not cover. I want one of these to cover, so I can say this to cover, this do not cover, so this has to cover, and this covers, right? This covers. Now I say neither of these needs to cover because I covered already, so they do not need to cover. So I'll go down here. This has to cover. This has to cover. And then that's another thought. Let me actually write this one down. I think maybe we can find something out from here. Now just like for every time that we have a parent and we have a child, a three situation, parent and two childs, only one of them gets covered. Only one of them has a camera, right? That's the basics. So if I do not have if I have camera, if the root has, and this does not have, this does not have, then must be covered. So I just randomly pick this get covered. So this do not have cover, so this get covered. This does not have cover, all right? And its child must have cover. So this one's covered. If this covers, this do not need to cover, so we pick this to be covered. This not covered, so this has to cover. Neither. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that situation we have 8, right? And then we're going back to the drawing board because every time we have two choices, right? We have two choices. We have actually, it depends. It depends. So where can we go? So this we can now go. All right, so basically like backtracking, right? Backtracking. So backtracking to here, and this one does not have choice. The choice is on like on this one. No, on this one. So I say this gets covered, and then the rest is deterministic, right? So on this we say, okay, let's switch. We'll say the right gets covered. Right, the right gets covered, so this does not get covered. and this does not give cover, so I need these two, right? So in this situation is 1, 2, 3, 4, 5, 6, 7. That's 7. 1, 2, 3, 4, 5, 6, 7. Yeah, that means it's 7. I think privilege is probably also 7. So okay, that's 7. So now we consider both situations. On the previous one, that can lead to multiple situations. So we say this one's not covered, so there's no choice. So this is the choice, left and right, right? So we change it. So we choose this to be covered, and this is not covered, right? So if this is not covered, so it has to be covered by its children. So this has to be covered, and neither of these children need to be covered. So they can be not covered, and this has to be covered. So this has to. So this is not covered. This is covered. So I now will go here, and this is not covered. All right. So this has to be covered, and this isn't already covered by this. So we go to this child. This is not covered. This is not covered, right? How do we do this? So children's get covered. The children is covered. So I covered, so I don't care. So I go to the child. The child is not covered. So we have to go see if I am not covered, then I have a choice, right? Yeah, if you go to a node, and the node itself is not covered, so I can either cover myself, and that's also a choice, right? I can cover myself, or we can have my children cover me. So I cover myself, and then the children cover me, or I don't cover myself and the children covers. So anyway, but that's like 2. We have to have 2. So it'll be 1, 2, 3, 4, 5, 6, 7. Still 7, right? That's still 7. Okay. So that's that choice. Now we're going up. What's the next one that I have choice is here, right? Because I choose to go this one. I'll go this one. Draw it again. Actually, I'm just throwing things out and see which ones stick. So I say I choose this one. I choose, let's go here. I say I choose this, get covered. Camera putting here. Camera putting here. I'll say we can do left or right. No, it'll cover here. So left or right, neither of them needs to be covered, right? So this doesn't have to, this doesn't have to. And then we go to here, and the choice is here. This one, whether I get covered or not. Now, I've actually done this already, right? If I get covered, I have some situation. If I not get covered, I have some situation. I already done it. And actually, I don't remember. If I get covered, I get what? If I get covered, I think the minimum I can get is 1, 2, 3, 4. 4, 5, 6, 7. It's still 7. Jesus. It's still 7, right? It's still 7 in total. But I say, if this gets covered, this gets camera, then the minimum of this subtree, right, will be 4. So 1. Actually, I don't know. 1, 2, 3, 4. Right? There's no other options if I get covered. And I can do this code 1, 2, 3, 4. Yeah, I think that's the minimum. If this one has a camera, then the minimum is 4. Because I have neither this one and basically these 3. That's 4. But if I don't get covered, then it's 1, right? And 2, and 3, 4. That's also 4, right? That's also 4. So whether I get covered or not, this subtree requires 4 cameras to do, right? And that's 5, 6, 7. That's still 7. Now, what's the next option? So we consider these two. The next option is this, because it's the entry point. We can choose to cover myself, or we can choose to have this to have camera, right? Now we have this as camera, then the left are they covered, the right are they covered? So we go down to this level. So these two, this I can choose to cover or not cover, and this I can choose to cover or not cover. On this side, we already done it. It's cover or not cover. This side is 1, right? This side is 1. Already done. So no question. So down here, so this side cover or not cover. I think we done this already as well. Like if we cover this, then if we cover this, then we go here. We say don't cover. That's 4, 5, 6, 7. If I don't cover this, then that's 4, 5, 6. That's 6, right? That's 6. Yeah, if we cover this, so whether we cover this or not, this is always going to be 4. So we don't cover this because we can use this to cover. I think that's a recursion. That's a recursion we can do with how do we do we use the value, right? We use the value. Actually, we cannot use the value, but we can use a global dictionary, and we use the address. We can use the address, so we can call it DP. It has to be like this, right? So that will be what? So each node, it has a cover or non-cover value. Like if now the camera on, camera off for each node. Camera on, camera off, and we can compute. And how do we do this? Can we represent this in some interesting way? Yes, we can. Yes, we can. If we iterate it and then we assign the value to unique numbers, then the DP can be just an array. And for each value, we have two sub values. It'll be like a 2D array. That requires us to go through it twice, which I'm not keen on doing that because we can do it using the other methods as well. So we can say, like say from collections import default dict, right? So this is going to be a default dict of list. Actually, it's going to be a lambda, right? And then we're going to return a 0 times 2 because we want to have 2 options, right? The values of 2 options, either a 0, which means I do not set a camera, or 1, I do set a camera. And then we're going to set def, it's DFS, right? It's a DFS, and we'll have a node, maybe tree node. Don't return anything. So what we do is, on a current, whether I'm covered or not. So it's going to be covered, like I'm covered, then I don't cover myself. If I'm not covered, right, then I need to find someone to cover me. If I'm not covered, then I can choose to cover myself or have my children cover for me, right? So there are 2 situations. If I'm covered already, then I don't cover again. I just pass along. If I'm not covered, so is covered, right? That's going to be Boolean, right? So I'm going to say if is covered. Right? If I am covered, and also if node, right? If not node, we just return, right? If not node, we just return. We don't have anything. If not node, we just return. Right? It's nothing to do. If I have a node and I am covered, then I don't worry anything. So we just go DFS, let's say node.left, and node.left, and node.right, because I'm covered, right? I'm covered. Then we say node.left is going to be the left subtree, the minimum on the left subtree. And node.right is the right subtree. And I will add them together. So this is going to be dp node is covered equals this plus dfs node.right, right? That's when I'm covered. Else, if I'm not covered, actually I can just make it int, make it more explicit, right? If I'm not covered, then I have a choice to either cover myself or not cover myself, right? The choice is to cover myself. So I'm going to say dp node to cover myself, right? So cover myself will be, I want to cover myself. And that will be, actually, this is going to pass because I'm covered. So I'm covered. Oh wait, hold on. No. Every node, right? Every node, we can say if I want to cover myself, if I don't want to cover myself. So every node has a choice to cover or not cover, right? So it means it doesn't matter, right? It doesn't matter. It doesn't matter. I can choose to cover myself, I can choose not to cover myself. Right? Yeah, I can choose cover myself, and then when I pass on, and I can also choose to cover myself and not cover myself, right? Those are always two pathways. And I cover myself, and then I go here, cover, and cover myself, and I go back, go both ways. So we have, so each node is if I cover myself, or I don't cover. If I don't cover, and I move on, hold on. What are we trying to achieve? We want to know the minimum number of cameras if I put a camera on myself or I don't put a camera on myself, right? That's what we want to know. The minimum number of cameras is required. So if I put a camera on me, right? So this is going to be how do we do this? So for the next one, do we want it to have a camera or do we not want to have a camera, right? So we have a node, there's a current node, and then has camera, right? Has camera, and that's something passing down to us, right? And if it passing down to us, it's, we'll just say has camera is going to be an int, right? And let's say if not node, right? We're going to return 0 or nothing, right? And we say if dp node has camera, oh, that has to be -1, right? If dp has camera is larger or equal to 0, then we return dp node has camera, right? Else, that means we haven't done it yet, then if, right, so if has camera, like I have camera on me, then I want to know the minimum of my children when they do not have camera on. Is that correct? Like if I have a camera on me, right, and I want to know my children, the minimum that they have a camera on or do not have a camera on themselves. Maybe if I have camera, then why do we do has or have or not have camera if we will like split into two and every single one of them? Because for each one, if I have camera, then I want to know the minimum of my, if I have camera on me, right, then the children doesn't matter, right? Children can, if I don't have camera on me, then both children has to have camera, one of the children has to have camera. So it has camera or not have camera, right? That's the basic. If I have camera on me, then it's gonna be the minimum of like all of them, right? So this is correct. Like else, right? Else. Whether I have camera or I do not have camera, doesn't matter. So what we're gonna do is if I have camera, right, then it doesn't matter. So we can say the minimum of dp node dot, no, not dp, we say dfs node dot left, right? Node dot left has camera, dfs node dot left, no, that's just gonna be one has camera and not have camera. The mean of this plus mean dfs node dot right has camera or mean, no, or dfs node dot right not have camera, right? That's the thing. Like if I have camera, then I don't care if my children has or has not camera. And this is going to be dp node has camera equals this. As if I have, if has camera, then we do this. Else, right? Else else, then that means I do not have camera, right? That means has camera as false and do not have camera. If I do not have camera, then will require at least one of my, so would be, if I do not have camera, it's going to be the left has to have camera, right? So it's going to be left has camera plus right, I don't care, right? Or it's going to be, so it's going to be the, all right, let's make it like this: minimum of this and this, right? Plus minimum of this and this, right? That's one situation, and this one will be just this plus gonna be the minimum of this and like, or we have minimum DFS node dot left 1 and DFS node dot left 0, right? Minimum of this plus DFS node dot right 1. So that means we have right is, but left we don't care, right? So that's, yeah, maybe we should just like do something like this plus something like this, right? So we have the mean plus mean, and the mean of these two together. That's if has camera, if not have camera. And actually we can say if this one is smaller than 0, right? If it's smaller than 0, then we have these two scenarios. And after handling these two scenarios, we're going to return this, right? And the result will be I'm going to return the mean of DFS root has camera on, or DFS root do not have camera on. Okay, let's see if this one will work. I'll run this code. Oh, Jesus. Come on, man. What the hell? If not, no, right? So DP node has camera because we have 2, right? So it's either 0 or 1. Smaller than 0, then we do it. Has camera, then we do minimum left. Either left has or left do not have, or right has or right do not have. And then we add them together, we put in here. Otherwise, it's going to be minimum. Because I don't have, has camera on me, I don't have. So we can left has, right we can have or don't have, or left have or don't have, and then right has, right? And then to minimum plus together. Oh, hold on. If I have camera, and this has to be I think plus 1, plot the plus 1, because I have camera, so I need the plus 1, because I don't have camera, so I don't have the plus 1. So now we run it again. Jesus. I get 2. I get 2. Okay, it's apparently not right. Right, apparently not right. Let's think about like the easy case, right? The easy case. So yeah, I think this is correct. We have to add 1 here. 1 at the left and right. So easy case will be easy case. This is a good test case. Let me just paste here, but we're going to do an easy case. Yeah, we're going to try this like maybe a few more minutes before we give up. This is an easy case. Let's see if the easy case got it right. Okay, easy case, we can get it right. Okay, let's go through, right? In this one, we can say we have it as 1. Right? If we have this as 1, then we go to this situation. Then we say node has camera equals 1 plus the minimum on the left, either 1 or 0, I don't care, right? Or on the plus the right, 1 or 0, I don't care. On the left, 1, so this has to have 1. And then this will be node 1 equals 1 plus its left and its right. Both are 0. So this one, if it's 1, it's going to be 1. If it's 0, then we go here, right? Then we say it's the minimum of, that's 0, and then that's also 0. right? So that's going to be 0. The minimum of this and this, that's going to be, so like if this one does not cover, then that is going to be 0. Right? This doesn't, yeah, if you say there's no camera on you, no camera on you. If I have a node and I say there's no camera on you, what is the result? I think it has something to do with this is the leaf node, right? And that's always tough with the leaf node. If I am a leaf node, then there's no such a thing as there's no camera on me, right? Because I need to cover. But the basis is I have to cover myself. So if not node, yeah. And if I say it's not being covered, and if I have camera on me, that's fine. If I don't have camera on me, then we have to make a choice, right? If I am not the, like here, we're going to say if node.left, if not node.left and not node.right. Like if I'm a leaf node and I say there's no camera on me, right? And that's not going to happen because it has to be a camera on me. Right? This has to be have a camera on me. So we say in that case, then whether you have a camera on me or you choose not to have a camera on me, both situations will result in dp node has camera. Like it doesn't matter. It will be 1, right? It doesn't matter because I am the leaf node, and the leaf node, if you're talking about whether I need to be covered or not, whether you have a camera on me, that's 1. If you don't have a camera on me, it's still 1 because I have to be covered. Otherwise, then I will give you a 0. And else, like if I'm not the leaf node, so this is specifically for leaf node, right? For leaf node, because leaf node has to be covered no matter what. Okay, if we add this situation, I mean, I think for the easy case, it shall still work. Doesn't work anymore. Ah, the logic is not correct. That means if I cover myself, right, and then if I cover myself, then this one we can choose cover or not cover, cover or not cover, right? And then they will all be 1. If I don't cover myself, then they both have to cover themselves. Apparently that's not correct. So the leaf node, if I don't cover, okay, so we still don't. Let's remove it. Apparently I think this one is not correct. All right, and then I think if I cover myself, and then if you're left, if I cover, that's going to be 1. If I don't cover, that's going to be 0, right? And then that's going to be 0 coming back. And 1, 0, 1. So this is going to be 1. If I cover myself, that is 1. If I don't cover myself, right? If I don't cover myself, then either this cover myself, and this I don't care. I don't care if it's 0, because this will be 1. Right? 1 here. And that's a problem, right? Because here, either I cover or I don't cover, because this one doesn't cover. Like, I don't have, this one doesn't have. Now we have 1 here. Shouldn't have 1 here as well, because I'm not covering myself, right? This I'm not covering myself. This one's not covered. If I'm not covered, then we say I only need 1 of these to cover me. If I have 1 of them to cover me, then for this situation, then it has to be covered, right? Like if I cover or I don't, like it's not covered. Like if I put a camera on me or I don't put a camera on me, it has to be covered no matter what. So in this case, I don't cover me, I don't have camera on me. So I say I want one of these to cover me and the other one, I don't care, right? But for the other one, I don't care, and I have 1 or 0, then I have a camera, that's good. If I don't have a camera, right, if I don't have a camera on me, then I want somebody to care for me. But then what I see is nobody can care for me. If nobody can care for me, then I have to become a 1. Right? Which means this one is not. If I can cover for me, if I can cover, then that's a 1. No, hold on. If 1, right? If I have camera on me, then I don't care if you have camera or not. Or do we make it strict? Like if I have camera on me, then you don't need to have camera. And then you don't need to have camera. And then both of you are covered. Maybe there are more situations. Have camera or have covered, right? Now we're talking about four different cases, right? 4 different cases. Yeah, have the camera or you don't have the camera. Like I can say I have the camera and I have the camera, but I do not have coverage. That's not true. If I have the camera, then I will always have the coverage, right? And if I don't have camera, then depends. I might have the coverage or might not have the coverage, right? So if I have the camera here, then this will be have a coverage, like have a coverage of a 1 and have a coverage, or 0 and I have a coverage. If it's 1, I have a coverage, then that's like duplicate. And as a 1, that doesn't matter, it's the same. If I have no camera, but I have coverage. If I have no camera and I have coverage, that means I don't care. I don't care, right? It's only when I don't have a camera and I don't have coverage, that's when I care, right? That's when I care. I need both to be good. But if neither is good, then I must have camera, right? Then that situation does not work. And I can return, like in that situation, I can actually return infinity, right? I can return infinity because it's fine. So we're talking about 3 different cases. Like have camera, not have camera but have coverage, and not have camera and not have coverage. If I don't have camera, don't have coverage, I need to have at least one of my children has the camera. And if I am the leaf node, then if I'm the leaf node and I don't have camera, and then we suppose I don't have camera and don't have coverage, and that is going to give you a bad thing. So how should we change this? Like if I've set it, so it is supposed to be 3 scenarios, right? 3 scenarios, and we can just code it. We say 0 is So 0 is what? Zero is no camera, say no camera, no coverage. 1 is no camera, covered, and 2 is camera. All right, so 3 situations. And then if it's going to be smaller than 0 that we haven't visited yet, then we say if has camera. No, we don't say has camera. I just say call it state, right? It's going to be a state. Everything is going to be a state. So if state equals 2, which means I have camera, right? If I have camera, then it has to be 1, and I don't care about the left and right. So it's actually going to be left. It's going to be 0, 1 is, and one more, right? DFS say no dot left 2. Like I don't care which one we go for. And then similar with this, it's going to be right. Now, it can be all 3 situations because I have a coverage. So the left and right, whether they have a camera, or don't have a camera, or have a camera with coverage. Well, actually, no. If the parent has camera, then the child will be covered no matter what, right? So the child will be no camera but with coverage. So actually, there's no 0 situation because that one doesn't exist. The child does have camera, does have coverage, but it can choose to have camera or not have camera. Now, Aleph, right? Aleph. Let's say state equals 0. So no camera and no coverage. Then, if I'm the leaf node, right? If I'm the leaf node, then this is an impossible state because I cannot cover myself, which means I can make this a gigantic number, right? So when I say, as I import math, I think I can make this a math.inf, right? If I am the leaf node, and there's no camera on me, and also I have no coverage, then that's an impossible state. So we just return it. Else, then we need to acquire. So I'm a 0, so no camera, no coverage on me. So I acquire either the left has camera, and the right will be the right we can, so I don't have coverage. So the left has camera and the right does not have coverage. So it can choose that's no camera, no coverage, or it has a camera, right? So only these two. So this no camera but with coverage is not going to happen. Or I can say the left is going to be either 0 or 2, and the right is must have camera. So right has a camera, left can be no camera, no coverage, or a camera. And the last state is going to be 1. So it's no camera. So for the current is no camera, but I have coverage, right? If I no camera, but I have, means I have already covered. Then that is the case where I really don't care. So, but I don't. Oh, hold on. So this is going to be similar to this, right? Because no, it's not going to be similar, but it will be similar in the right up. So this is going to be 2, 0, 1, right? So no camera, but I have coverage. So the children do not have coverage. So children do not have coverage, right? Children do not have coverage because I don't have camera. So children do not have coverage. So do not have coverage or no camera, or they have camera. But instead of adding 1, because I don't add 1 because I don't have a camera, but I have coverage. So those are the 3 different states. And after we handle those states, we do this, And what we do is on the root is going to be either no camera, no coverage, or it's going to be have a camera. So we try it again. Oh man, if this one still fails, I think I'm going to check the answer because it's getting really late. Okay, so test this. First the test case, very complicated. Ah, still not right. I thought this is already pretty good. Right? I thought it's pretty good. Like, what else I did not consider? Right? There's only 3 cases. Because if I have camera, I have coverage. There's no, like, no camera, no coverage. No camera with coverage, or with a camera, which means I have coverage. And if this is a state, it's smaller than 0, that means I haven't considered u before. If I consider u, I say the state is 2. If the state is 2, that means I have a camera. If I have a camera, then for the children is going to be either no camera with coverage, or the children can have a camera, right? So it's these 2 states. On the left side, minimum on the left side, minimum on the right side, and because I also have coverage, so I have camera, so I have to add 1, right? If it's 0, means there's no camera and no coverage. If it's no camera and no coverage, then if I'm a leaf node, that's what I say. If I'm a leaf node, then I say this is an impossible state. Or maybe I should do it 1. If it's impossible, but I say it have to be 1. No camera, no cover is impossible, so I have to do 1. Or in other cases, it's going to be the minimum of 2 situations. So either the left has camera, or the right, I don't care. Right? The right, I don't care. It could be no camera, no coverage, or the right has it, or the left do this, right? And the third situation is no dot left. This is 1. No camera but with coverage. No camera but with coverage. So the children will be similar to this, right? But I don't care because they don't have coverage, so it's going to be 0, or they're going to be having this. But I don't have to add 1 because I already have coverage. I'll try it again, just change this to 1. Let's see if it's right. That's still 5. Oh my god. Oh my god. And I even like I don't know, man. I don't know. I think I got everything. Maybe it's here. Because I'm returning the minimum of the 2. So if I do this math.inf, and I do math.inf here as well, let's try this. The answer is inf. How? Which one's affecting? Don't do this. That's why? So like that's a leaf node. That's gonna be 1, right? But regardless, if not null, it's gonna return. So, but the leaf node, has other things, and then the min is going to be okay. Okay, so what if I handle leaf node differently? Right? What if I handle leaf node differently? If I am a leaf node, and if I'm a leaf node, then I say if I'm a leaf node, if I have camera, that's going to be 1. If I have no camera but covered, that's going to be 0. If I have no camera and no coverage, that is going to be impossible. Let's try that. So basically just say if, like, instead of doing it here, right? Instead of doing it here, I'm still trying to salvage this solution because I feel the solution is correct. It's just like if as a leaf node, right? And we say if state is equal to 0, then this is going to be math.inf elif state equals 1. This is going to be 0 because I don't need anything. Else if 2 is going to be 1. So we don't have to do this. Well, we actually still need to do this. Hold on. I think this has to be 0, right? It has to be 0 because that is to handle a case of like a single branch. Oh no, that's not a single branch. This has to be math.inf. I think this is to handle these cases, right? So when I have one branch, the other branch is nothing. But I don't want this branch. If I become 0, then that one is going to be affect me, right? That one is going to be affect me. I don't want that to affect me. It has to be coming from here. So it has to be this. And the reason why I do this is because if I use this all the time, then the leaf node will have max, have inf on both sides. It's not going to work. That's why I take the leaf node out, consider that separately, and also consider this separately. Actually, we are going to actually this has to go first. This is the this has to go first, right? And reach a leaf node. Yeah, let's go first. All right, let's try it again. Hopefully this one correct. Oh. Why? Why? Like, which one is having the problem? I'm doing min. Zero root 0, which just means no camera coverage. No camera covered. Actually, there has to be no camera covered as well, because it is possible. Root 1, no camera covered. Maybe that's the case. That's still inf. Still in. Okay, let's do 0. So we do the leaf node separately. And then we do 3 situations. That's also 5. That's still 5. Very frustrating. Very frustrating. I feel like this is correct. That's the thing. I feel like this is correct. But if I don't consider it separately, I have no clue. Probably still gonna be 5. That's gonna be 2. Yeah, that's even more wrong, because the leaf node is not considered. Yeah. You have to consider the leaf node. It's 1, 0, otherwise it's gonna be 1. Let's see another case. This one is too complicated to analyze. Do this. This is correct. We find like a smaller case that they're all correct, man. They're all correct. Oh, it's very frustrating. It has to be like a very convoluted case in order to fail. Oh, that's doesn't matter. Oh, it's not a valid type of tree. This is a valid type of tree. Well, it's all correct. How about this? Weird looking. Oh! This one. I say 2, expect answer is 3. Why would you say 2? Well, we say there's 3 situations, right? We say 0, 1, 2. How do we handle this? Let's cheat a little bit. So I'll put numbers in it. Right, 2, 3, 4, 5, right? And then here instead of node, I'm gonna say, it's not, we're gonna say, yeah, we're gonna cheat a little bit because that's the only way I can debug this thing. So instead of saying node, like when I say dp node, right? When I say dp node, right? Whenever I say dp node, I actually going to do node dot val, right? And then at the end, we are going to say, which we're not going to return, we're just going to do, we're going to do these 3. I'm going to say rest equals min this, right? And then let's say print dp, right? And then return res, something like this. Kind of trying to debug this thing. See if we have efforts to debug will come out with something nice. To kind of give us a root consists of value in 0. Oh, yeah. It requires. I can't even debug like this. Then I don't know the position. Okay, no. We can. So still get it back to 0. It is possible to know. There is a way. We just go through it, right? Res equals this, and then we're gonna do another DFS, right? When it's a def again, def traverse node, right? And then at each node, just print out, and we're gonna do in order, right? So be root, left, and right. Root, left, and right. So we're just gonna say if node and print dp node, right? And then traverse node dot left, traverse node dot right, and then we can call traverse root and then return res, something like this. And then I can have the printout. Yep. Now we can check. So we say, so it's going to be in order, root, left, right, and then root, left, right, root, left, right, and root, left, root, left, and root, left. So it'll be this, and this. Okay. Let's see, what do we have? And here, that's the last one is on this one, right? So that's infinity 0, 1. That's correct, because that's what we say, infinity 0, 1. And again, 0 is no camera, no coverage, no camera, no coverage is infinite. Correct. 0 is camera, no camera coverage. Yeah. So these two is correct. How about this one? Now this one, we can do 0 is no camera, no coverage. If I don't have camera and don't have coverage, then what I want is this one has camera. So this one's 1, right? So it's 1. Good. If I have no camera, but we have coverage. No camera, but we have coverage here. And this one. No camera, but we have coverage. So I have coverage, but I don't have camera. But in this case, I say I don't really care, right? That's 1. I say I don't really care. Then it should be mean of DFS here. Either this one doesn't have camera and no coverage, that's an infinity, right? That's an infinity, or this has coverage. Then it's going to be 1, so that's 1, right? Or it does have camera, so that's 1, correct. Looking here, this one. If I say I have no camera, no coverage, then let's say this has camera. This has camera, that will be 1, right? And plus 1 already. If this has camera, and then the minimum on this, this one will be if I have camera, if I have camera is this situation. Then it's going to be, if I have camera or I have no camera, but I have coverage. So it's going to be these two, right? The smaller of these two. That's a 0. And the left will be this one, smaller of these two. That's going to be a 1. So this is going to be a 2. And the 2. Actually, why is it 2? Oh yeah, that's a 0. That's a 0. That's a 1 plus 1. That's a 2. Right? So here will be minimum will be 2 cameras. If this one has no camera, but I have coverage. No camera, but I have coverage. But I don't care. So the minimum of this will be no camera, but we have coverage with 0 and 2. So 0 and 2, that's going to be 1. 0 and 2, that's going to be 1. So this is going to come up 1 plus 1. That's 2. Yeah. So, or I say no camera, no coverage. No camera, no coverage. So either the left has camera, so this has camera, that will be 1. Has camera, right? That will be 1. And the right, don't care. Now right, don't care will be, that's the end, no. Right, don't care will also be 1, that's 2. Or left, don't care. Left, don't care will be 0 or 2. That's still 1. And then right has 2. Okay, so this one is 2. No matter what, this we require 2 cameras, which is true. Either this has camera or this has camera, or these two has camera. So that's 2. 2 to 2. Okay, that's good. Now we have 2 more left. So that's 1. That's already 2. So we at least have 1. How come it's a 2, 2, and a 3? Anyway, so this is a 2, 2, 2. So coming in this one, right? If I have camera, then the left side, that's the problem. The left side's a no. It gives me 0. It gives me 0. Right? It gave me, so both are 0. Oh, it shouldn't really matter, right? It gave me 0. So no dot left, no matter what, it's going to be 0. Then no dot right. And then give me the small of these two. And the 2, right? And then plus 1. That's 3. Correct. If I have no camera and no coverage. So no camera, no coverage. Let's do the no camera but with coverage. I have no camera but with coverage. So I say left, I don't care, left is going to be 0. And the right is going to be 2, because that's a 2. That's how we got 2 here, right? But is that possible? Yes, it's possible. No camera with coverage. No camera with coverage, because that's a 2. This one's a 2, always 2. So I have this as coverage, then I don't have only coverage here. So that's 2. That's actually correct, right? That's correct. And I have no camera and no coverage. Then, no camera, no coverage. If I have no camera and no coverage, no, hold on. If I have no camera, no coverage, that's when this has, that's when it's 2. If I have no camera with coverage, that's I don't care, right? I don't care. But this is still in the 0, and this is going to be 2. So that's why it has 2, which is makes sense. No camera, no coverage. No camera on me, and I don't have coverage. I have 0 coverage, I don't have coverage. Then how is that state possible? If I had no camera, no coverage. Oh yeah, that's typo. No, if I have no camera but I have coverage, then basically that means I don't care. I have coverage, then this one doesn't have coverage. Yeah, that's fine. Now there's 2 to 3. I think that's correct, which means if I remove one of the node, I can remove the root node, then that's give us 2. Yes. Now we add this. Now this is the problem, I guess. But that's 2 to 3, right? That's 2 to 3. And for here, if I have a camera, right? If this one will have camera, then it's going to be the mean of left and right, and be 1 and 2, so that's going to be 3. It's correct. If I camera, so this is the camera, camera, and camera. 3 camera. Perfect. If I don't have camera, but if this one doesn't have camera, then I require like a 0. If there's no camera and no coverage. That's impossible, right? And we cannot have the first one with no coverage. We cannot have the first one without coverage. First one must have coverage. Either it's no camera with coverage or with a camera, which means the 0 situation is not going to happen because I cannot have no camera and no coverage on the initial state. It has to be covered one way or another, right? Yeah, that's true. So now it becomes -1, so we don't consider. So now the question is a no camera but with coverage. No camera with coverage which means it's going to be this one. And then we're coming here. That's still 2, right? All of the situations is going to be 2. This is all 2. So if I have camera, right, it requires you have camera. I think I almost got it. Hold on. So it's this situation, right? So no camera with coverage. Hold on. No camera but with coverage, or no camera, no coverage. If it's no camera, so no camera, no coverage is my current state. Then I will require the children to have cover. Yes. If it's no camera with coverage, it means my parent has cover for me. So actually it's not true. It's actually 0. I can do no camera, no coverage. Then my children cover for me. But I cannot do no camera with coverage because I don't have parent. This is a result. The result won't change, but I think it's clearer, right? So there's still it's gonna be no camera, no coverage. If I have no camera, no coverage, then it's going to be this has to have coverage, right? 0, right? So it's going to be whatever left or right has to have coverage. And then the right is this one, 2 is going to be return 3, right? That's 3. I say or left, no, does the left have coverage? And left has coverage and the right, but left cannot have coverage because left is impossible to have coverage on the left. So that's where we have the problem. We need to check, right? We need to check. So it's here. We need to check if it's 0, right? Then we need to check. Like how do we check? We need to check because this I really don't care. And this I already covered, and honestly, I also don't care. The only thing I care is if I don't have coverage and I don't have camera on me, so I must have a child cover for me. Therefore, I will check. if I have a left, right? So based on like have a left or have a right. If I have a left, then if I have a left and a right, then we do this. If I only have a left, yes, that's when we happen. That's when it happens. So if node dot left and node dot right. If I have a left and I have a right, then we'll do this. Perfect. Like it's make perfect sense. Elif node dot left. If I only have node dot left, then dp node state has to equal dfs node dot left 2, right? Elif node dot right, then I must have the right. Else, that's this node, right? That's this node, which we can just say is going to equal. That's impossible. This is the impossible situation, right? State is 0, and I am the leaf node. That's impossible because I don't have children. I don't have children, which means I think this one we don't need this anymore. Then we can delete this. Right? This we don't require. And then we run it. This one's correct. Right? This one's correct. And if we run this, and let's not traverse it, let's just run it. Let's see if it's 6. Name res is not defined. Of course it's not defined, because I also comment on this one. Now let's see. Now, oh, I have confidence now. So I think we can just return this. All right, submit. Let's see. Yes, 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 yes. Oh. Oh, 2 hours. Oh, 2 hours. Wow. It's it. It is a DP. Wow. I mean, I'm not supposed to do it this way because we have a rule to stop at 1 hour. It's actually 45 minutes, but I see the end of the tunnel. Like it's the analysis starts to come in. Right? The analysis starts coming in. So I have more and more confidence in this, and that's why I decided to stick with it. How are you gonna write? I'm just gonna say this is also like a state machine, right? So there are 3 states node can be in. 0 state. Yeah, we can copy and paste this entire thing. 0 state, no camera and no coverage. 1, no camera with coverage. 2, camera and of course with coverage. The idea is to compute the minimum number of cameras needed for each subtree, needed for the root of each subtree. The idea is to compute the minimum number of cameras needed for the root of each subtree for all 3 states. Then the solution would be the minimum of the 0 and 2 state of the root, of the overall root. We can use DFS to do this along with a DP, along with a cache, along with memoization. The tricky part is when is the 0 state, because we have to consider whether the node has left or right child. In the 0 state, a node must have camera either in the left or right child. Thus, if the node does not have left or right child, it must force the other child to bear camera. Of course, if the node in question is a leaf node, then it is impossible to be in 0 state. Thus, we return math.inf. Then, after we run everything, what's the runtime of this? Well, the runtime we have 3 states, but each time we split, and then on each one we split twice, right? So basically you can think of this as at each level we split to 4, right? We split to 4. And so if we split into 2, that's O(n) log n. If we split into 4, I actually don't know. Each one we go left. The left is 0, left 2, right? So we basically we split into 2 into 4. I used to know this. Isn't this still O(n) log n? Like no matter how many you split, how many times you split, but with more states, right? With more states, split into 4. Man, I don't know. Don't know. I should know. Like we have a recursion cost and a merging cost, right? So the recursion cost is going to be isn't the recursion cost going to be what? N squared. I think it's the recursion cost is recursion cost is what, n to the log 2n. I think that's the recursion cost. Log something n. Log something. That's log. One split. Each one is 4n. Split 4 times. and each one is yeah, each one we split into 4. I'm gonna say 4T1 because after you split, it's all 1, right? So this is going to be n to the log 4, I think. Or as I can be 4 to the log n. Yeah, I think it's 4 to the log n. And then we switch, this is n squared, right? On squared. And the other one is O1. So we take On, I think it's On squared. I think this On squared I was using the master theorem, but I kind of forgot how master theorem goes. I think it's On squared. All right, let's just end it fast and then, 68 milliseconds. A very bad runtime, huh? 6%. Ranking. All right, let's take a look at the solution. Man, this is pretty hard for me. Pretty hard for me. Especially when today was yeah, I mean, I don't want to talk about it. It's a good question. When we solve it ourselves, I mean, it doesn't happen very often. Oh, wow. Greedy On. That's not On squared then. I think it's On. No. From the top of the tree, every node considered must be covered by a camera at a node or some neighbor. We care about local state. We can hope to leverage this fact for the entire efficient solution, especially when we're deciding a place to place a camera. We might place a camera to cover some subset. Solve. State 0, strict subtree. All the nodes below this node are covered, but not this node. Normal subtree. All the nodes below and including this node are covered, but there's no camera here. Place camera. That's this, right? That's this. We have a camera. Place a camera, and all the nodes below and including this node are covered, and there is a camera here, which may cover nodes above this node. Yeah, I think that's similar thinking, but so stage 0 is no camera, no coverage. Stage 1 is no camera, but with coverage. In state 2, yeah, I think it's the same state, but why did you write it so much easier? Why did you write it so much easier? And without DP at all. Let's see. Return 3. Okay. So I say, if not node, return 0, 0, and inf. If not node, then no camera, no coverage, and no camera with coverage, or have a camera. Well, you cannot have a camera because it's not a node. That's why we return an inf. But no camera, no coverage. That's a 0. And no camera, because we don't put a camera, so we say 0, okay? So L equals solve no dot left. R equals solve no dot right. Okay, maybe it is ON. Maybe we don't need a DP. And DP is 0 and L1 plus R1. I think it's it's this situation, right? This situation will be L1. Hold a sec. But now this one, below are covered. So DP0 must be in state 1, but if the children of this node must be in state 1. Nah, not necessarily, right? If I am now covered, then my children has to be covered. Only one of them needs to be covered. Yeah, I think even if I don't set up this, I think it will work as well. No, this is only one of them needs to be covered, right? And DP1 is I got covered. Is this? Yeah, it's the same. Hold on. No. I think that the 0 is not what we think it is. Below this, include this are covered, and there's no camera. No. I think it's wrong. 0 means. I think this 0 means. Actually, I don't know what this means. I honestly don't know what this means. This looks like this. Like 1 must be covered. Like left must be covered. So the DP1 is, yeah, that's let's say I am covered. Okay, I think there's a slight difference. DP0 is I am not covered, right? I don't have camera, and I don't have camera on me, but my children are all covered. But not this node. Like, I am not covered, right? I am not covered, but my children's all covered. In that case, we say, oh, because I am not covered, and I also don't have camera, but all my children's covered. So the only possible way for that to happen is both need to cover me. Yeah, okay. And then this is, I am covered, but I don't have a camera. Then one of the children must cover me. Yeah, or I have a camera. Then we don't care about what to do with the children. Children can just take a minimum. And then when I solve 1, because I have to cover myself. So it's similar, but the thing is, I do it more complicated, right? So I say no camera, no coverage. That's similar to this, right? But I say if it's a no camera, no coverage, that's a no camera with coverage. So like I'm already covered. I think it's different thinking. What I'm thinking is a no camera, no coverage is when I enter the state, I say I have no camera and I have no coverage. Then my children has to cover for me. Like how do I make myself covered under the current situation? That's my state. How do I make myself covered under the current situation? But actually, I think it's possible not to use DP, which might save me some time if you think about it. Right? So, yeah. Okay, I want to solve this using this setup, but my thinking. Now, this is a good thinking. I kind of know. This thinking is just top down, right? I, not covered, no coverage, right? If I am in this state, what next one needs to be done, right? or I am in a state of no camera but being covered, right? If that's the state, then what's my children need to be done, right? Like if I have no camera but I covered, then my children must cover me, right? Must cover for me. Hold on. Why do children have to cover for you? If I don't have a camera and I am covered, yeah, but because we think about the root node, right? If I don't have a camera and I am covered, then the root and the children must have covered for me. In my case, is if I have no camera and no coverage, how do I get covered? Right? This different. One is already have the result and try to find out how the children need to do to make this result. And my thinking is the initial one, and the current state is the initial state, and how do my children have to do? Like this, like the entering, right? This is like the entering state. What I'm trying to do. But I'm gonna code this using this kind of thinking, but I'm gonna not see it, right? So what I'm trying to think is this from the solution, right? My state, but with the official solution, with the logic in the official solution, with the logic in the official solution. So what do I do? Well, I have 3 states. Still, I have 3 states. So again, we have a DFS node, right? And we're gonna return a tuple. I like this idea. The int. Let's just return a tuple. Just don't make it too much moves here. So it's gonna be a tuple, right? And the tuple is gonna be the value of 3 states. So let's say if not node, right? We're gonna return. If I enter the not node, and I say this one is going to be no coverage and no camera, no coverage. Well, it's a no cover, so it's a 0, 0, and the math.inf. I agree completely how this one's going to be. Now, if I have one, then I say I'm just going to do left equals DFS, no.left, right equals DFS, no.right. Right? So we get the left, the 3 states on the left and 3 states on the right. And then I say state 0, S0 is going to be, state 0 is still same, no camera and no coverage. That's how we enter the state. If I enter the state is no camera and no coverage, what should I do? Well, if I have no camera, no coverage as enter, then we require one of the children must be has a camera, right? So we're going to return to this state. So it's going to be minimum something something, right? And then that's going to be L. We say you must have a camera, right? Left has a camera plus right. Don't care. Right going to be either 0, which means no camera, or 2, have a camera, because I don't have coverage, right? So I have no camera, no coverage. So the left has camera, so it can cover for me, and if left cover for me, the right I don't care. But I don't have a coverage, so right does not have coverage. So it's 0, and L. No, it's be right, right? Right 0 and right 2. Because it cannot be on 1. It cannot be no camera with coverage. The only state is this. So it's going to be this on the right and left side. So I'll repeat the same thing on the left side. Right. So if the root, saying if the root is under the state, when I enter the root, is no camera, no coverage. then how do you cover the root? Right? That's my thing. This one is going to be no camera, but I already have coverage, right? I already have coverage. If I have coverage, then I don't care, right? I don't care what the left and right do. So it's going to be just a min and a min, right? So I don't care. You can, but you cannot have coverage. So you either, so it's going to be 0, 2 as well. So it's going to be 0 and 2. It's also going to be 0 and 2. It's R. Right? Or it's 2. I have coverage. If I have coverage, then the children must have coverage, or they can choose to have, right? So the R1 and R2. And we're going to return S0, S1, and S2. After that, we're going to return the minimum. All right, we're going to say res equals DFS root, right? And I'm going to return the minimum of res 0, which is no camera and no coverage. So I need somebody to cover for me, or res 2. It cannot be res 1, right? So I can say, let's first try, see if this one works. Run the code. Why is this not correct? Why is this not correct? I mean, slightly different from what. Zero or 2, right? Not that left, not that right. That's a 0. It's going to be minimum of this plus this. 0, 2, 0, 2. 1, 2, 1. Oh, I forgot the 1. Okay, let's try it. Yeah, this is much faster. I forgot the 1 here. Now the difference between my states and the official solution states is that my state is consider when we first enter a node. We want to answer the question of how the children, how the subtree should behave in order to rescue my current and rescue the root, rescue my state. Therefore, my 0 state requires at least one of my children to have camera. The official solution state are after the fact. After the fact. This means a no camera, no coverage state is what happens after everything is considered, right? After everything is considered. No, I think it's still different. Yeah, I think the official solution is that we don't consider parent node. So it's no camera, no coverage, no camera with coverage. Yeah, I mean, so it's like I'm the root node. I don't consider any parent node from me. States strictly consider the root node as the beginning, right? Strictly consider the root node as the beginning. Therefore, a no camera, no coverage root node means that both the child node must have camera. Otherwise, they cannot be covered, right? I don't know, man. If root node is a no situation, like it's the empty, like there's no coverage. The root node has no coverage. No, I don't like it. I don't like it. I like how I think about it. This is just the enter node. I want to answer the question of how the subtree should behave in order to rescue, in order to handle, in order to reconcile with my state. At least because I'm under my state, I have this this condition, so I need my children to be. Yeah, I like my way of thinking, right? And um, apparently, we do not need to use external memoization, and the runtime, is actually on, not on squared. Yeah, this is actually wrong. This is wrong. It's on. You can see very clearly here, but you can't see it from here. It is on. Okay, we have another solution, which is greedy. Cover bottom up. If a node has its children covered and has a parent, then it is strictly better to place the camera at this node's parent. And has a parent, then it is strictly better to place the camera at its parent. Children that are not covered by the camera, then we must place a camera here. Yeah, because from bottom up, right? If a node has no parent and is not covered, we must place a camera there. So DFS, we always go left, right, or all the way to the bottom. pair. What's pair? Pair is none. And node not in covered, or node.left not in covered, or node.right not in covered. So that means if parent is none, like if I don't have parent, and node, I have node, not in covered, I'm not covered, or node.left not covered. Okay, I don't have parent, and my left, I'm not covered, my left not covered, and my right is not covered. Then I say I must cover, I must put myself in. Children not covered by camera, so I must place a camera here. Okay, so it has no parent and is not covered. I must place a camera here. I think that's to cover the edge case of a single node. Otherwise, if a node has its children covered, if the children is covered, then if the children is covered, then I don't cover. Yeah, if I have my children covered, right, and my parent is also covered, and it has a parent, not cap. I don't know about the parent, but the parent has a cap. If I have a parent, and I have my children covered, already covered, then my children is already covered, then I do not cover myself. I wait until my parent to cover for me. All right? I mean, I don't know. I don't know. Greedy DFS. So the root of a tree to be covered by the left, right, or itself. Leaf of the tree covered by its parent or by itself. The leaf, camera can cover the leaf and its parent. We set camera at its parent, the camera can cover the leaf, its parent, and its sibling. The second plan is always better than the first plan. Now we have only one option: set up camera to all leaves parent. Set cameras on all leaves parent, then remove all covered nodes. Repeat step 1 until all nodes are covered. I think that's the same idea, right? It's the same idea. All right. If not root, between 2. What was 1, 2? 0 is a leaf. 1, if it's a parent of a leaf with a camera on its node. 2, if it's covered, but without a camera on its node. But still different states, right? But we go to the bottom and then say if that's child, which is a leaf, then it needs a camera. If it has a child, which is a leaf, it has a camera. If it has a child, which is the parent of a leaf, then it's covered. It needs camera, and return 1. It's parent of a leaf with a camera on its node. If it's covered, it return 2. Otherwise, it returns 0. So look left, roll right, and try to see which one they are. If they are the leaf nodes, then, or like something like a leaf nodes, right? Or like it can be a giant leaf nodes. Then we return 1 and say I am the parent of a leaf node. But if one of them is a 1, means one of them has covered, right? So just think about I'm the root, and then on the left and right, if one of them is covered as a camera and cover, I think one is a parent of a leaf with a camera on it. It's covered with a camera, right? It's covered with a camera. It's a cover without camera, right? So cover with camera or cover without camera, or the leaf. So we know the leaf is 0, right? No question about it. The leaf is a 0. The leaf is a 0. So if I see that I am the parent of a leaf, I'm gonna put a camera and cover myself, right? And if I have something already covered, like if my left or right child, one of them is already have a camera, then I don't need a camera. So that means I am no camera but covered. That's 2, right? No camera but covered. No camera but I'm covered, right? That's definitely return 2. And this, no camera but covered. Otherwise, so none of them is 1, and none of them 1, then that means there are 2, right? Have none, so it's going to be 0. That means that's I'm the leaf node. Self-DRS. Look at the solution again. Let's think about it again. It is bottom up, right? Because bottom up for the children, for the leaf, if I put camera on the leaf, then I cover leaf and I cover my parent. But if I put camera on the parent, I cover leaf and I cover my parent. So that's a better solution. So every time when we hit, like every time we always cover the parent of the leaf, right? And after we cover the parent of the leaf, we work backwards up, right? So I have parent of the leaf, and we say that means my children. If my child, one of my child has already been covered, then I say I do not cover because that will be a waste. So I don't cover. Okay. If I don't cover myself, then I return a 2. I will state as a 2, right? And if I have a node whose children both are 2, so they're now covering, that essentially means that that I become a leaf because my children, they got covered. Hold on. The children return 2 if they, yeah, and then I return 2. If both are 2, then I return 0. That means I am the leaf. Oh yeah, I am the leaf. Yeah, if both my parents are covered, then I am the leaf because they're both covered, so they will not change. So I become a leaf. So I don't have anybody to cover for me, right? I become the leaf. Therefore, my parent has to cover for me, right? My parent has to cover for me. What if I don't have my parent? What if I'm the root? Therefore, at the end, you also have to check the root. Like if I'm the root, and then nobody's, and if I'm the root and I'm the leaf, oh yeah, if I'm the root and I'm also the leaf, then I have to cover for myself. Okay. Yeah, I have no Ghana to code anymore. I think I'll just call it a day. We did do it, so that's good. Okay, that will be it. I will see you guys tomorrow then. Adios.